All right. Today we start our new unit. Okay, let's talk about a firefighter for just a second. Although I think it's funny because it never talks about a firefighter, but whatever. A fire truck can get 12 feet from the base of a burning building. Why? Why can a fire truck get 12 feet from the base of a burning building? But why don't they get closer? Oh, because the building's on fire. Oh, okay, okay. And why don't they get further away? So they have a firm basis for their ladder, right? Okay. So the extension ladder is used to reach the upper floors. Because the ladder can be extended to various lengths, it can reach higher and higher up the side of the building. So let's answer these questions below, all right? If the ladder is extended to a length of 13 feet, then how far above the truck can the ladder reach on the building? So the most popular wrong answer, what do you think it is? Before we even do this, before we even mess with it, what do you think people automatically think the answer is? 1. Why do they think it's 1? 13 and 1, 13 and 12. Let me start over again. 12 and 1 is 13, right? So it should be 1, all right? We are smarter at math than that. We know better, right? Of course we do. Okay, so they give you an idea of the shape that they want you to use right up there. They even give you a picture of a little fire truck. That's actually probably a big fire truck, but relatively speaking, it's little. Okay, I mean, I wouldn't want a fire truck that size coming and fighting a fire at my house if I had one. A toy, right? Okay, so let's draw ourselves a picture for this specific problem. What's what? What goes where? Well, 12 goes at the bottom. Good. Where does the 13 go? Oh, the 13's the ladder, right? That would be the 13 right there. So what we're trying to find is this. Now, you already told me you think 1 is wrong, correct? Right? Okay. So how do we figure this out? You know, Pythagorean theorem, right? You called it that 1 formula earlier, and I knew what you were talking about. Okay. So in this, right, exactly, a squared plus b squared equals c squared. In this particular problem, it is x squared plus 12 squared equals 13 squared. How do I know that the 13 is the one that's squared? It is the hypotenuse. Good. Okay, good use of math language. Proud of you for that. So what is x squared? Do I know it? No. What is 12 squared? Do I know it? 144. Excellent. What is 13 squared? Do I know it? 169. Okay. How do I solve for x? So one of them, the first thing I do is subtract 144. Excellent. X squared equals 25. Good. And then square it both sides. We're doing math here, right? We're doing math. We're solving an equation. We're not paying attention to this part up here right now. All we're doing is the math, right? So somebody please tell me the square root of 25. I heard a lot of you say 5. I'm not disagreeing with that. What are you missing? What times what equals 25? I agree with 5. I promise I'm not disagreeing with that part. What times itself, another thing, is also 25? -5. You remember that? Remember when we take the square root of a number, we have to have the plus or minus 5? You remember that? Okay, now we've done the math, right? The math says the square root of 25 is plus or minus 5 because 5 times 5 is 25 and -5 times -5 is also 25, correct? Now let's answer the question to the problem. How far above the truck can the ladder reach on the building? Can it be -5 feet? No, not in this problem, can it? Can we ever have it a distance that's negative? Yes, but not in this situation, right? So our answer to our problem is what? 5? Oh, 5 feet. Because we're truly trying to answer the question, aren't we? Good. What height can be reached above the truck if the ladder is extended to the length of 15 feet? Well, let's draw it. I know that's going to be 12. And I know that is going to be 15, right? The hypotenuse is going to be 15. Again, I don't know this distance, so we can call it x. I heard some people talking earlier, and I think I confused you. That wasn't my intent. Up here in the problem, that height is a y, and I used an x. I'm sorry if I did that. I just automatically leaned toward x. So if I confused you, sorry. We're good? Okay, good. X squared plus 12 squared equals 15 squared. Do I know x squared? Do I know 12 squared? 144. Do I know 15 squared? 225. How do I solve for x? First I subtract 144. Good. I get x squared equals 81. Then I square root both sides. X equals plus or minus 9. Very good. Now answer the question that's being asked. 9 feet. In this problem, let x equal the length in feet in which the ladder is going to be extended, and y be the height in feet that it can reach above the truck onto the building. Complete the table below. Well, let's see. We already did this one, right? That's 5. And we already did this one. That's 9. How do we do the rest of them? Plug them in. Okay, who's going to do 12 for me? Volunteer. You got 37? I need 12. You got 30? I've got 30 and 37. You got 12? What do you got? 20? 25? Thank you. Why don't you do 25 as well? Somebody else do 37? I know you got 37. I want 2 people doing every single one of them so we make sure we get the same answers. Fair enough? So if you didn't volunteer for one, go ahead and do one anyways, so that we make sure we have at least 2 people doing for every number. Okay, good question. 6 letters has a good question. What happens if you get a decimal? Can you have like 4.5 feet? Oh, yes? Okay. So how many decimal places should we go to in this particular problem? What would be logical? A 10th place would be okay. 100th place would also be okay. Okay? Any past that, that doesn't really make sense in the context of this particular problem, because we want to talk about feet. Okay? All right, once you get your answers, go and let me know. Okay, so who did 37? Okay, so what did you guys get? Did you guys all get the same thing? Yes, 35? Excellent. Who did 12? Anybody else do 12? What'd you get? Oh, 0? 0? We'll have to talk about that in a minute. 20? Excellent. 25? Perfect. 30? So we're struggling a little bit on 30. If you didn't do it before, go ahead and do it real quick now. Okay, good. 27.5. Okay, before we go on, let's talk about this real fast. Does that even make any sense? If the distance from the truck that you can be from the building is 12 feet, sorry, let me scoot it down, like this, and the ladder is 12 feet, where's it going to be? Right out the back of the truck. It'll just be touching the building right over here. So does it make sense this is not any height above the truck? Yes. Okay, good. Alright, so the next thing it wants us to do is graph these points over here on this graph. So please take the time and plot those points if you haven't already. 13, 5. Notice the scale of the graph as you go. The x-axis, which is the length of the ladder, is counting by 2's, and the y-axis, which is the height of the truck, is counting by 5's, isn't it? I mean, every second line is by 10, so each line is counting by 5's. Millish and 37. 37 is 35. Does yours look like mine? So this crazy kid earlier was like, that's not a straight line. Guess what I said? You are correct. That is not a straight line, is it? So are we talking about linear functions anymore? No. Okay? By definition, lines are straight, aren't they? So this cannot be a line. Okay? You got this okay? Wait, do we connect them? We're not going to right now. We just want to see the scatter plot for now. Okay? A function to model the relationship between the length of the ladder and the height can be extended above the truck is this. F of x is the square root of x squared minus 144. Where the heck did that come from? We subtracted 144 on each side, and then we took the square root of each side. Is that what's happening here? I subtracted 144 and then took the square root of it? Does that make sense? Okay. Oh, look, where does this function come from? Where did it come from? Pythagorean theorem. You're right. Well, you did say it earlier. I knew you knew the answer. It's okay. To see the graph, you may have to change your calculator's window. What window settings would match the graph on the preceding page? Well, what's the easiest way to figure that out? Yeah, look back at the graph on the preceding page. What's the x minimum on this graph? 0. And what's the x maximum on this graph? 50. 0 to 50. How does it count? What's the scale? Either by 2's or by 10's would be okay, wouldn't it? Okay, so I'm actually going to write 2 or 10, just so you can make the choice yourself. All right? What about the y? How low does it go? 0. How high does it go? 45. Okay, so 0 to 45. And how does it count? By 5's, right? 5's or 10's would work in this case. I'm going to go ahead and write 5's. Okay? So go ahead and type this. Okay, first of all, remember some of these worksheets are written back for the old calculators, the ancient calculators. They're fine. We just don't have them anymore. Okay? So you cannot actually follow these rules to enter into calculator because we don't have a y equals menu anymore, do you? Open a new document that is a graph and enter it on the entry line. enter the equation on the entry line, and then what do we press to go see the table? Control T. Okay? Start a new document. That is a graph. Psst. Where's your calculator? Oops. I'm going to start a new document that is a graph. On the entry line, I'm going to put in the square root of x squared minus 144. I messed up. Do I need to zoom out, or do I need to fix my window like we just said? Fix my window, menu, window, and I want to edit my window settings. Okay? So that needs to be 0. Tab. That needs to be 50, tab. 2 or 10? I think I'll go with 10. Why? Because that is 0, tab. That is 45, tab. And that is 5. Tab, enter. Does that look like the graph I got before? What? No, change the window to the window settings. Does that look right? It does, right? Okay. Alright, so now we need to go to the table. So Control T. And I need to scroll till I can see the values of 5, 6, 7, and 8, right? Let me scroll. Mine must be broken. No? You don't think it's broken? Really? So on my paper, I'm supposed to write error, 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 error? And that's right? Okay, because anytime I see error, I always freak out that I did something wrong. And by me, I mean you guys do that. Explain what this means in the context of the problem. Maybe that'll help it make sense. What does it mean in the context of the problem? What does X stand for? The length of the ladder. And what does Y stand for again? The height above the building. So when the ladder is 5 feet, there's an error? If the ladder only goes to here, 5 feet away, it is not touching the building, is it? Or 6 feet, or 7 feet, or 8 feet? The ladder, how do I want to write this? Is too short. Thank you. And just to clarify, I'm going to put it won't reach the building. And then I'm going to put a frowny face. Okay? What does it mean in terms of the numbers? Like with the formula and stuff. What if I put in a 5 for x right here? What's 5 squared? What's 25 minus 144? A negative number? What does a negative under the radical give us? Imaginary numbers. And I don't know about you, but if I'm a fireman, I do not want to be climbing on an imaginary ladder. Okay? So, what are we going to write for B? What does it mean in terms of the numbers? The numbers under the radical are negative. And just to clarify for myself, I'm going to put imaginary numbers. Probably a better thing for me to put would be complex numbers, because there is a real part and an imaginary part, but you know what I mean, right? Okay. What's the domain of this function? It doesn't have one? Okay, well, it has to. For this particular function, what is x allowed to be? 12, right? 12 is the lowest it's about to be, right? And if we're confused, let's look back at the graph. For us visual people, how far to the left is this allowed to go? 12. Can it go any further? If it does, I get negatives under my radical. I don't want that. Oh, excellent. X is greater than or equal to 12. How many of you are going to take pre-cal next year? How many of you have to take another math? Okay, and you'll probably take pre-cal. I need to show you something. That means exactly the same thing. Okay? This means exactly the same thing. I start at 12 because it's less than or equal to 12. And I go to infinity. I use the brackets if I know that number is included in my answer. Why do I have to use a parentheses on infinity? Do I know where the end of infinity is? I don't know where the end of infinity is, so I just have to say and the rest of it, right? I can't say that that answer is included in it because I don't know where it ends. Okay? I just want you to be familiar with that. This is how we're probably going to talk about the answers in here. Okay? What about the range? It only goes to 0 and doesn't go below it, right? So how do I write that? Y is greater than or equal to 0. I do that sometimes too and put x, right? But we're talking about range, so we want to use our y value. How would I write it in this notation? Do you know? Bracket, 0, and infinity. Okay? How do the numerical domain and range relate to the original word problem? Like, how do I translate this to take it back to the problem? Okay, let me write that down. That's good. The ladder can be 12 feet or, what'd you say? Longer? And can reach what? Can reach what? 0 feet or higher above the truck. Does that make sense? Any questions about that? Okay. So supposedly this is one of those real life situations. Chances are when firemen get to a burning building, they don't get a ruler out and measure 12 feet. Okay. Probably the person who's driving the truck has a pretty good idea of where he can park and where he can't. Okay. After they put the ladder up the side of the building, they probably don't measure it. Right? But what's happening in their head? They know that there's math going on it. They're concerned with the fire, aren't they? Okay? So we can be concerned with the math so they can worry about the fire. This is the second page I gave you today. It's called Extra Practice Solving with X Squared. Okay? This is just some basic square root problems where we're solving using square roots. Also, notice that we are going to be solving with factoring and the quadratic formula because I got to keep that in your head. Okay? So we're going to go over number 4 and you're going to do the rest on your own. Okay? Number 4. Look at number 4. What should we do first on number 4? Wait. Time out. Why can I solve using square roots on number 4 and not on number 5? First of all, it says factoring. That's good. Good reading the directions. Let's do number 4 and then try to start number 5. How about that? Is that a good deal? Okay, so what would I do first to solve number 4? Add 35. Good. 8x squared equals what? 63 and 35 is 98. Then divide by 8 on both sides. X squared equals 12.25. And then what? Square root both sides? Okay. When I square root both sides, what do I get? X equals what? Oh, okay. Plus or minus 3.5. Okay. That's right. Are there any questions about that? So let's start at number 5. Let's pretend we're ignoring where it says solve by factoring, because most of you do anyways. That was just a little joke, sorry. What should we do first? Add 24 to both sides? What does this problem have that this one doesn't? An x term. Can I solve with square roots like this if there's more than one term with an x in it? No, I cannot. Which is why they recommend factoring for this one and why they recommend quadratic formula for this one. Okay? We can't just automatically start adding 24 to both sides and then somehow just randomly take a square root just because there's an x squared. Okay? So you have the rest of the period to work on this. I need you to get 1, 2, 3, 5, and 6. I need to be very clear on number 1 and 2, however, because this has been a problem. Okay? It's a silly problem, so don't worry. All right? It tells you the problem. It gives you a shape, like a triangle to look at, and then it gives you choices. And so a lot of people just start working the problem, and look right here. There's a box that wants you to put your work in. If you put your work in that box, that is so great. If you do your work out here by the actual shape, that is also so great. Don't get to the end and then rewrite your work just to have it in the box. You want to put it in the box, great. You want to have it up by the actual shape, that's great too. Fair enough? Okay, any questions? Ask as you go. I do have the answer key pulled up on my computer if you want to check as you go as well. Okay?